Hello guys, welcome to yet another video of Maths Made Simple with Ms. Gamu. I know it's been a long time coming. Many of you have sent me requests on this video on the ultimate revision pack of fractions, decimals and percentages. I know that mid-year exams are around the corner and you really need to ace your fractions, decimals and percentages. This is the video to watch. Alright, without wasting much time, let's get into it. So the first thing that we're going to focus on is comparing and ordering fractions, decimals and percentages. Most teachers and most examiners always want to test your knowledge whether you're able to order fractions, decimals, percentages. Usually it will look like this, where it's a mixture of your decimals, your percentages and your fractions. So one of the key things that I always used to do is making sure that you put all of these guys into one unit. So at the end of the day, either you put all of these as decimals, or you make them all percentages, or you make them all fractions. Then you're able to order them. Most of the time, some examiners will tell you to order them from smallest to biggest. Some examiners will tell you to order them from largest to smallest, ascending or descending order. It doesn't matter. The key is to first put them in the same unit. For me personally, the easiest unit is to make them all percentages. All right, so let's dig in. So the first one being this 0.70. 0.70 is a decimal, and we want to go from a decimal to a percentage. So the easiest way is to say 0.70 times 100, because remember, whenever you hear the word percentage, it always means multiply by 100. So whenever you multiply by anything with a multiple of 10, you count the number of zeros. Here we have 2 zeros, and that means you're gonna move your decimal point to the right 2 times. So 1, 2. So our answer is 70%. So that's our first one. We can put it aside here, 70%, right? Cool. Then the next one is already a percentage, which is 80%. We put it there already. It's already in a percentage. Then we have 3/4. So 3/4, that's 3/4. We want to convert this into a decimal. Then we go to a percentage. That's the easiest way. So how you do it, if you're using long division, you take the denominator or the one at the bottom, you put it outside your division, then you put the numerator on top. Then you're going to ask yourself, how many times does 4 go into 3? It can't. So you're going to put a 0 point. Then you add a 0 to the 3. How many times does 4 go into 30? It goes in 7 times. Now 7 times 4 is 28. Okay, we subtract. We're left with 2. Can 4 go into 2? No. We bring down a 0. Then we say, how many times does 4 go into 20? It goes in 5 times. So 3/4 is 0.75. And 0.75, if we multiply by 100 and move our decimal points 2 times, we have a clean 75%. Alright, cool. Then 0.81, the same way, we multiply or we move our decimal point to the right 2 times, so that will be 81%. Okay, so we're only left with 4/5. We use the same method where we put the denominator outside and we put the numerator inside. And we say 5 goes into 4, it can't. We put a 0 point, then we add a 0, then 5 goes into 4, 40, 8 times. So that's another 80%. So if we are ordering these from smallest to biggest, the smallest is 70%, which is 0.70. And remember, whenever you're ordering them, put them in their original units that you were given by your teacher. But sometimes some teachers don't really mind if you put them in your converted versions, mainly because it is actually the same. So the first one being 0.70 Then the next one being the 75%, which is the 3/4. Then the next one being the 80% and the 4/5. So 80% and our 4/5, and the last one being 0.81. All right, so just as a recap, whenever you're comparing and ordering fractions, decimals and percentages, you always put whatever parameters you're given into the same unit, whether you make them all decimals, you make them all percentages, or you make them all fractions. And when they are all in one unit, you're able to order them, because you can't order them if they are not yet converted, because it will be very, very difficult. All right, see you in just a bit. All right, the next step of our fraction, decimal, percentage booklet, revision booklet, is finding the fraction or percentage of a quantity. One of the key things about this section of fractions or percentages is that this is actually something you can use in daily life. So I don't know if you've ever seen, if you go to the shops and you go to the mall and they always say this product is 20% off, or there's a discount of 5%, or a quarter of the price is off. This is actually what this is. So it's actually something that is very practical that you can use in your daily life. All right, let's jump into it. So the first one we're going to deal with is finding the fraction of a quantity. So the first one says, what is a quarter of 28? So I'm going to write there a quarter. But before I go there, there is a key to understand here by understanding what does off mean. This off that I've written here. Off simply means to multiply. All right. So for the rest of your mathematical career, if you hear someone say what is a quarter of something, or what is 20% of something, off means times. Again, off means times. All right, so a quarter times or multiply 28. Whenever a 28 is by itself, you can give it a denominator, which is always 1, because 1 goes into 28 times. But this just gives a bit of an easier way to calculate, especially you'll see when we go further. So now the first step that you're going to ask yourself is that, how many times does this 4 go into 28? So if you know your 4 times table, we know that 4 goes into 28 7 times. All right. So now we're going to say 7 times 1 equals what? 7 times 1 equals 7. So that is our answer. So a quarter of 28 is 7. Notice the method we used, we first divided the diagonal, then horizontally we multiplied. So I've given you two sums because I want to give you another method. So 2 over 3 off means times 60. So another method, yes, 60 over 1. So another method, instead of dividing first, you can even multiply first, then divide. Although it's a bit longer, but there are many ways to do mathematics. So 2 times 60 is 120. All right. Then 120 divided by 3. 3 goes into 12. How many times? 4 times. 3 goes into 0, 0. So 2/3 of 60 is 40. All right. If we are using this method, we would have done 3 goes into 60. How many times? 3 goes into 60 20 times. Then 20 times 2 is 40. It gives the exact same answer. All right. So now let's move on to the percentage. So one of the key things is this: whenever you hear the word percentage, it always means out of 100. So 20% actually means 20 out of 100 or over 100. All right. So we already know that off means times 120. All right. Over 1. So there is another small method that I want to teach you. It's called a 0 for a 0. So whenever you have diagonals or when it's vertically opposite each other, you can cancel out a 0. So we can cancel out that 0 for that 0. We can cancel out that 0 for that 0. So what is left? Here, what is left is a 2. What is left there is a 1. What is left there is a 12. What is left there is a 1, right? So now we can either use the multiply then divide method or divide then multiply method. So in this case, if I say 2 times 12, that is 24, right? 24 divided by 1 just gives me 24, right? So that's our answer. Alternatively, you could go the long method where you're gonna say 20 times 120. Then that answer you divide by 100. It will still give you the same answer, but it's very long. But we'll see with this next question. So this question says 15 over 100 times 80 over 1. All right, so if we are sticking with our 0 for a 0 method, we're gonna take that 0 for that 0, but we can't take any other zeros there because that 15 doesn't have a 0, so we will have to say 15 times 8. All right, you use your method. 15 times 8. 8 times 5, 40 is 0, carry a 4. 8 times 1, 8, plus 4, 12. Alright, so what are we left with? We are left with 120 divided by 10. Alright, cool. Now, 10 goes into 120 how many times? A 0 for a 0, it goes in a clean 12. So our answer, 15% of 80 is 12. So just as a recap or as an overview, remember that off means times, and you either divide the diagonals, then multiply the horizontals, or multiply the horizontals and divide the answer afterwards. So practice makes permanent in math. Keep on practicing and you'll get it. See you in a bit. Okay, the next step is adding and subtracting fractions. Most students find this quite difficult, but it does not have to be difficult. I'll show you the methodology to do it. So the key thing when adding and subtracting fractions, what you want to do is you want to have the denominators the same, all right? So as we can see here, the denominator here is a 2, the denominator here is a 7. So you ask yourself, what number can 2 and 7 all go into without leaving a remainder? In other words, what is the common factor between 2 and 7? So we're gonna, the life hack is just multiplying the 2 and you find the common factor. So 2 times 7 is 14, right? So we've established that 14 is the common factor. So now we want to make these two the same. So how are we going to do that? We're going to multiply by 7. Whatever you do at the bottom, you do at the top. All right? Then on the opposite side, we'll multiply by 2. Multiply by 2. So now, the revised version is that 1 times 7 is 7 over 2 times 7 is 14 plus 3 times 2 is 6 over 7 times 2 is 14. So now, when the bottoms are the same, the answer will also still have the same bottom. So what you have to do is to add the tops or the numerators officially. So 7 plus 6 is 13. And that is our answer. All right. So there are actually many methods on how to add or subtract, but most of my students find that this is the easiest and that's what I'm going to use. but I can show you other methods. But what I'll do is, let me show you another method for the subtracting. The concept is still the same. You're trying to make the denominator the same. So in this case, I'm gonna ask myself, what is the common factor of 8 and 5? So the common factor of 8 and 5, as I told you, the life hack, you just say, what's 8 times 5? That is 40. So I'm gonna put a line here, and I'm gonna put the 40 here as the common factor. Now I'm gonna ask myself, how many times does 8 go into 40? All right? 8 goes into 40 5 times. Then I'm gonna say 5 times 7. What's 5 times 7? 5 times 7 is 35. Okay? Minus 5 goes into 40 how many times? 5 goes into 40 8 times. So this side, I'm going to say times 8. So 2 times 8 is 16. Okay? So our bottom is 40. And we're just going to say, what's 35 minus 16? Okay, let's work it out to be accurate. 5 minus 6, it can't. We borrow. That becomes a 2. That becomes a 1 there. 15 minus 16 will give us 9. Right? 2 minus 1, 1. That is 19 over 40. All right? So that's the method on how to add and subtract fractions. So as a recap, always make sure that the bottom or the denominator is the same. So either by finding a common factor, making sure that the bottoms, the denominators are the same. Once they're the same, that will be the answer there. Then you just simply add the top or the numerator. Or in this case as well, finding the common factor, dividing into them, multiplying the top, subtracting or adding. So it doesn't matter, either you're adding or subtracting, the method is the same. You just have to find the method that is easier for you. All right? Okay, see you in a bit. All right, we're gonna move on now to multiplying and dividing fractions. This, especially multiplying, many of my students find this the simplest because we just go straighty daisy. We just go straight. All right, so we're just gonna multiply numerator with numerator, denominator with denominator to get our answer. Are you sure? Yes, it is that simple. All right, so 4 times 1 is 4. 3 times 2 is 6. The only key thing is you need to simplify. So we have to find the number which divides into both 4 and 6. And that number is 2. So if we divide by 2 there, whatever you do at the top, you always do at the bottom. All right? 4 divided by 2 is 2. And 6 divided by 2 is 3. And that's your answer. So you can always just go straight. There are other methods, but we are in the business of making math simple. So that is it. Maths made simple. Let's go. So the next one is, for me personally, one of my favorites. Mainly because there's a nice cool song here. The song goes like this. I don't know if any of you love, just like me, you love some KFC. But this one is just a slightly different. Instead of KFC, it's KCF. What does this stand for? This stands for keep, change, flip. Again, keep, change, flip. Keep, change, flip. So what does it mean? It means that whenever you're doing a division sum for fractions, whenever you're dividing fractions, the first element there, you keep it as it is. The second element, it changes from a division to a multiplication. Then the last element flips That means whatever was at the bottom, aka the denominator, becomes the numerator. And whatever was at the top, aka the numerator, becomes the denominator. Alright? So you keep the first element, you change the division sign into a multiplication sign, and you flip the last element. The 4 which was at the bottom is at the top. Then what do you see? This is exactly that guy. So we just go straight. So we're just gonna say 1 times 4 is 4. 3 times 9, 27. Is there a number which can go into these guys? No. So that is your final answer. Alright? So just as a recap, when you're multiplying fractions, we just go straight. Numerator times numerator. Denominator times denominator. Then you just simplify. But when you're dividing, we use our awesome adage. Keep, change, flip. So just remember of your awesome Kentucky chicken. That will help you always remember. Alright? KFC, KCF. Alright? See you in a bit. Alright, we're gonna move on now to improper fraction to mixed and vice versa. That's why I put these arrows. So you can either go from a mixed number to an improper fraction, or you can go from an improper fraction to a mixed number. So the key is to know the methodology. So when you go from a mixed number to an improper, we use what we call the smiley face, sad face, multiply, add. Alright, I'll repeat: smiley face, sad face, multiply, add. So what does this all mean? Well, it means this. What is 2 times 3? 2 times 3 is 6. Then that 6 that you got, you add whatever is the numerator, which is 1. So our answer will be 7 over 2. And we see that this is an improper fraction. An improper fraction is a fraction where the numerator is bigger than the denominator. It always reminds me of our awesome green friends, the aliens, where the head is big and the body is small. Alright? So an improper fraction is where the numerator is bigger than the denominator. Alright? So whenever you do these, you multiply the denominator with the whole number, then you add that answer with the numerator. Alright? Then whenever you do the vice versa, when you go from an improper to a mixed, the first thing you ask yourself is, how many times does 9, like in this case, how many times does 9 go into 44? So you can count. Let's count in 9s. 9, 18, 27, 36, 45. Alright, we end there because we're already above the 44. So how many times? Let's count. 1, 2, 3, 4. So it goes in, 9 goes into 44 4 whole times, right? So now we want to find out from this 36 to 44, it's how many times? Alright, so that's the shortfall or the remainder. So the remainder, we already see that 45 will be the next one, which will be 9. So it's just going to be 8. So the remainder is 8. If we count from 36 to 44, it is 8. Then over, the denominator never changes, over 9. The beauty of this is this. Whenever you go back, you can go back to the improper. So if we say 9 times 4, we know that 9 times 4 is 36. And 36 plus 8 will give us 44 over 9. Alright? Even if we go back here, if we count in twos, 2, 4, 6, that's 3, remainder 1 over 2. So there's always that relationship between mixed and improper and mixed. So this is a very, very simple. I think in fractions, that's the simplest thing that you can ever do. Going from a mixed number to an improper and from an improper to a mixed. So that's a cool relationship because sometimes you get sums where you have to add or subtract or multiply or divide proper fractions with improper or proper fractions with mixed numbers. So you have to be able to know the relationship between these two. So yeah, see you in a bit. All right, we saved the best for last. That is dealing with unknown fractions and shape fractions. All right, so most of the students find these ones quite difficult, but it's a thing of you understanding the methodology and how to do it. All right, so let's deal with this sum. So this sum says Gami is thinking of a number, right? So we don't know the number. The number is unknown at this point, right? She says 5/3 of my number. So that is, okay, let me just quickly write that down. So 5/3 means 5/3 times, remember of means times, that number, I'm just gonna put a question mark, is 55. All right, what number is Gami thinking of? All right, so 5/3 of another number is 55. So there are many ways to deal with this, especially for the older kids who now know how to deal with algebra and equations. They can use that question mark as an unknown number, as an unknown variable like an X or a Y. But for my primary school kids, it's a little bit challenging. But there are certain hacks that you can put that can make this very, very simple. So the easiest method I found for you to deal with this is using what we call inverse or opposite operations. All right, so we know that this 5 is multiplying a number, right? Then this 3, because it's under this line, it's dividing. All right, so we just do the opposite. So we're gonna take the 55, right? And whatever was dividing, that is the 3, we do the opposite. The opposite of divide is multiply. So we're gonna multiply 3 instead of dividing 3. And because 5 was the one who was multiplying, we're gonna divide by 5. And that will give us our answer. All right, so let's work it out. What's 55 times 3? Let's work it out here. It's always important to work out your sums. 3 times 5 is 15. And I put a 5 there, carry a 1. 3 times 5 is 15 again. Add that 1. That means that's 165. All right. We put our 165 there. But we're not done. We're gonna say divided by 5. All right. I'm gonna use my short division. 5 goes into 16 3 times. Remainder 1. 5 goes into 15 3 times. So the number that Gami was thinking of is 33. All right. How do you know that's true? We need to test. Always test. So let's say, I'm going to do it here quickly. 5/3 times 33. If we get 55, we are correct. Remember the method I taught you? 3 goes into 33 how many times? It goes in 11 times. Then 11 times 5 is a clean 55. You see that? Not so difficult, was it? Now let's move on to doing shapes. So one of the key things that you are asked when you're dealing with shapes, whether you're given a square, whether you're given a triangle, circle, and as you go further in your mathematical journey, you'll be given 3D shapes and stuff like that. But now when it comes to this, and they've given you this, most of the time they ask for 2 questions. They ask you, what is the perimeter? And they ask you, what is the area? All right. So perimeter is the distance right around a shape. We have a rectangle. Rectangle has got two pairs of equal sides. So that means this side is also a third and this side is also 3/4. Cool. So now, whenever you're doing the perimeter, we're gonna add the easiest being 1/3 plus 1/3. Let's try and make it as small as possible. 1/3 plus 1/3. Remember, when the bottoms are the same, you just add the tops. That's 2/3. Then 3/4 plus 3/4. 3/4. Bottom stays the same. Add the top. 6/4. Right? So now, let me just make some space here. So perimeter would be the 2/3 we got plus the 6/4. Right? What's the common factor between 3 and 4? 12. 3 goes into 12 4 times. 4 times 2 is 8. Plus 4 goes into 12 3 times. 3 times 6, 18. 8 plus 18 is 26 over 12. Notice this is an improper. We want to make it a mixed. So 12 goes into 26 2 times. Remainder 2 over 12. So that is our perimeter. The distance right around this shape is 2 and 2 over 12. Let me just make my 2 pretty there for you guys. Now we're gonna go to area. Area, you just multiply the two sides. So that is 1/3 times 3/4. Remember, with area, you just multiply the tops. The top with the top, the bottom with the bottom. Numerator times numerator, denominator times denominator. 1 times 3 is 3. 3 times 4, 12. Simplify. 1 over 4. Centimeter square. Square centimeter. Always area is square centimeter. Alright, so just as a recap, whenever you're dealing with an unknown number, always use the inverse or the opposite operations. And whenever you're dealing with a shape, make sure you know the formulas. Perimeter, distance right round. You're adding everything. Area, you're multiplying the two sides, especially if it's a rectangle or a square. But as we go further, we'll deal with the specific formula for that specific shape. So guys, this has been a lovely revision booklet. Watch it, and watch it again. Put all your favorite series on hold until your exams are done. Watch this video. It will really help you. I hope you guys understand, and I wish you all the best in your exams. See you in the next one.